Now friends, in the earlier class we discussed about the single phase induction motor which is not self-starting. Now in this class we discuss about the different methods and the types of single phase induction motors that are available in the market or in the commercial way. Single phase induction motors employ the principle of faceplate for the purpose of starting. First we will see the that is the principle of faceplate. This principle involves phase splitting of the main field winding, that is nothing but when two windings space 90 degrees electrical apart on the stator of a motor are excited by two alternating EMFs that are displaced by an angle of 90 degrees in time phase, a rotating magnetic field is produced. If these two windings so placed are connected in parallel to a single phase source, the field produced will alternate but will not revolve since the two main windings are equivalent to but one single phase winding. If however an impedance which is that is either resistance, inductance or capacitance is connected in series with one of these windings, the currents may be made to differ in time phase. Hence, by proper selection of such an impedance, the currents may be made to differ by as much as 90 degrees, thereby producing a rotating field very much like the field of a two-phase motor. This is what the principle of phase splitting, and the single phase induction motors employing this principle for starting are known as split phase motors. These split phase motors are of different types based on the impedance. So if resistance is more dominating in one of the winding and if it is used for starting purpose, we take it as resistance start motor. Similarly, if it dominates capacitor in one winding for starting purpose, we call it as capacitor start motor. And if a capacitor is always continuously taken into the circuit, that is both under starting conditions as well as running conditions, then we call it as a single value capacitor motor. Similarly, if two capacitors are employed for starting purpose and running purpose, we call it as two value capacitor motor. Coming to the construction features, simply the stator is similar to what we have seen in the three phase induction motor, where it consists of stator teeth and stator slots, and the slots are fitted or filled with these windings, that is the main winding and auxiliary winding. So the starting winding, which we call it as main auxiliary winding, is provided so that together with the main or working winding, the motor can stimulate a two-phase motor to develop torque at start. In case of permanent capacitor motor, the auxiliary winding remains in the circuit after starting and thus closely approximates a two-phase motor also when it is operating under load. Hence, the term split phase may rightly be applied to all of the above mentioned single-phase motors. In practice, however, it is high resistance starting winding that retains the name, while those that use a capacitor to split the single phase are called by the particular capacitor circuit required. Except for the single value capacitor motor, all the motors are provided with a cutout for the auxiliary winding. This cutout is done with the help of a centrifugal switch that remains an important element in the starting winding circuit. One important advantage of a centrifugal switch is that it opens at a predetermined speed and subsequently closes at a lower speed when the line switch is open and the motor is brought to rest. It is thus not subject to fluctuations in line voltage or to current variations for sudden change in load. So in this single phase induction motors, the main winding usually occupies only 2/3 of a pole pitch, and this makes it possible to achieve a winding factor of 0.827, and the remaining empty 1/3 of the stator slots can be used for the auxiliary winding, whose axis is shifted in space through 90 degrees with respect to the axis of the main winding. In order to provide high resistance and low inductance, the starting winding is wound with fewer turns of fine wire and placed on the top of the stator slots. The main winding, on the other hand, is wound with thicker wire and placed at the bottom of the stator slots. The idea behind it is that the current through the starting winding is nearly in phase with the line voltage than is that through the main winding. This gives the effect of splitting the single phase applied to the motor terminals. Now let us see these different methods of starting of single phase induction motors with the help of their schematic diagrams as well as the phasor diagrams. Coming to the first one, that is very simple split phase motor. You can see here two windings as shown in the diagram, and the circle represents the squirrel cage type of rotor. And this winding we call it as main winding, and the current passing through it as that is running current or the main current. And this is another winding which we call it as auxiliary winding, and where the current passing through that is taken as high starting. The purpose of naming this high starting is only at the time of starting this winding comes into picture. after running conditions, this switch opens up, and this winding will be out of the circuit. So this switch we call it as the centrifugal switch. And for an instance, the angle between the two currents is taken as approximately of 30 degrees, which is represented in the form of a phasor diagram as shown here. The red phasor represents the starting winding current, and the green phasor represents the running winding current or the main winding current, and the resultant of these two is giving us the total current IT, which is nothing but starting from the source. And with respect to the applied voltage Vt, this current is obviously lagging in nature. So here the main current that is passing from the source is split up into two parts with an angle of phi, and approximately as an example here. So that gives us the rotating field within the stator. That rotating field is enough for us to make the rotor now continuously rotating. This is very simple principle of split phase motor, where this is what the schematic diagram, and this is the phasor diagram. Coming to another type of motor, that is capacitor start motor, where we can see that this capacitor is connected in series with the main winding, of course centrifugal switch as usual, and this is what the main winding. The purpose of this capacitor is to increase or to make the angle between the two current, that is starting current, that is auxiliary winding, and the main winding current more or less approximately of 90 degrees with respect to each other. That makes us, or that gives us, an effective torque production within the induction motor. So the purpose of this capacitor is to make this angle between these two currents more or less 90 degrees, and hence you are going to get the rotating magnetic field far better when compared to the simple split phase motor. And coming to the other one, that is capacitor start and run motors, where we can see for running conditions a running capacitor as is shown here, which is always there in the circuit along with the auxiliary winding. And for the starting purpose, this capacitor comes into picture. Starting purpose in the sense, when the supply is given to this induction motor, when the speed increases or goes up, and if it is near to synchronous speed or something about 70 to 80% of the speed if it reaches, then this centrifugal switch automatically gets opened up, and hence the capacitor will be out of the circuit. But the auxiliary winding with another capacitor in series with it will always be continuously in the circuit, and the purpose of this capacitor is to make or to get the power factor improved always for running conditions. So power factor is also very much important in all induction motors, where we need to maintain it always near to 1. Hence in that aspect, if you want to make it near to 1, then better to add a capacitor in series with the auxiliary winding, and this circuit must be in continuously exist whenever the motor is in operating conditions. Hence this motor is known as capacitor start and run motor. And coming to another method of motor, that is shaded pole induction motor, where we have a stator as shown like this. There are cut portions in the stator, where the black portion gives us nothing but shaded band, and this is the starting winding, and this one is the squirrel cage rotor, and you can see here this is the salient pole structure of this induction motor, that is 4-pole shaded pole construction. And this shaded band plays an important role in this principle of working of induction motor. Now we will see when the supply is given to the main winding or this induction motor, we can observe that this shaded band is in the circuit, which plays an important role. That is, based on the Lenz's law, the EMF that is induced in this shaded band will oppose the cause. The cause for that is the increasing flux in the bottom direction, and hence the current that is produced in the shaded band will oppose the main cause, that is nothing but the main flux. Hence the current produced in the shaded band will be in such a way that the flux of this current will oppose the main field flux. Hence there will be less flux here and more flux towards the left of this stator. Similarly, for the second portion, if you see, that is at the instant T2, there is no change in flux linkage, and hence there will not be any EMF induced in the winding, and hence the flux will be of uniform in nature. Therefore the axis of the main field winding will be in the middle of this stator. Similarly, for the third instant, that is at T3, the net flux will be shifting towards right. So hence for this motor, the net flux is getting shifted from one direction to another direction, which does mean that there is a revolving field or rotating field that is produced. This rotating field is enough for the rotor to get rotation, which is similar to that of a three-phase shaded pole, or three-phase induction motor, squirrel cage induction motor. Now this is what the shaded pole motor and the types of single phase induction motors. Thank you very much.